Okay, so I'm going to be going over 9.1, adding and subtracting rational expressions. In case you're not here already, it is on page 425. So adding and subtracting rational expressions. The essential question, or what you should be able to achieve after finishing 9.1, is how can you add or subtract rational expressions? So we're going to get started on Explore. And the first thing we're going to do is identify excluded values. So given a rational expression, identify the excluded values by finding the zeros of the denominator. So it says, if possible, simplify the expression. So for starters, it wants us to identify the denominator of the expression. So looking at our denominator, we have x minus 1. And part B says, since division by 0 is not defined, remember anytime you have a fraction with a number on top and 0 on bottom, that is undefined. So since division by 0 is not defined, the excluded values for this expression are the values that would make our denominator equal to 0. So we're going to take our denominator and we're going to set it equal to 0. And so that's what we have right here. X minus 1 equals 0. So if I add 1 to both sides, I'm going to get x equals 1. So what you could say is that for this rational expression, x cannot equal 1. Right? Or if it says find the excluded values, then you would say the excluded values are x equals 1. But we can't let x equals 1, otherwise we're getting an undefined expression here. So part B says, begin simplifying the expression by factoring the numerator. So our numerator, if you look, you have 1 minus x squared, and you can kind of think of this as 1 squared minus x squared, which is difference of squares. So if I factor this, I would have 1 minus x and 1 plus x. And now it says divide out the terms common to both the numerator and the denominator. So our denominator here, let's see. I'm sorry, our numerator, not our denominator. Our numerator here, we have 1 minus x, 1 plus x. And then what they did on the bottom, if you look, we went from x minus 1 to a negative out front. What they did was they divided out a negative. And if you divide out a negative, what's a positive divided by a negative? A negative. And a negative divided by a negative is a positive. And then they just rearranged that. So they put the negative on the outside and they put the 1 minus x. And that's how they got this denominator down here. So they did that because now you should be able to see that this 1 minus x matches this 1 minus x. And then that negative 1 that we're dividing by on bottom, well, we have a negative and a negative. So my final answer is going to be negative 1 minus x. Simplify the the simplified expression is, and we just did all that work here, so our answer was negative 1 minus x. Wherever x does not equal, remember what did we say x cannot equal? X cannot equal 1. Okay. What is the domain for this function, and what is the range? So the domain, remember, is all the x values. And so the only excluded one that we've pointed out is that x cannot equal 1. And so our domain is all real numbers except when x equals 1. And for our range, well, now remember, we got this simplified expression here, and we know that x cannot equal 1. So if x equals 1, we would have a negative 1 minus 1, and so the range can be all real numbers except when y equals negative 2, right? Y will never equal negative 2 because x cannot equal 1, and if I plug in 1, I would get y equals negative 2. So the next part says reflect. What factors can be divided out of the numerator and the denominator? So think about this. If you have a fraction and you are going to divide something out from what's on top and what's on bottom, what do we know about these two things? Well, if I had like x plus 1 and x minus 1, could I divide those out? No, right? But if I had x plus 1 on top and x plus 1 on bottom, then I could divide those out. So what they need to be is what factors can be divided out of the numerator and denominator? Well, common factors, right? They have to be the same thing in order for us to divide it out. So let's move on to the next page, page 426, and let's go over explain 1. So explain 1 is writing equivalent rational expressions, and it says given a rational expression, there are different ways to write an equivalent rational expression. When common terms are divided out, the result is an equivalent but simplified expression. So example 1 says rewrite the expression as indicated, and it says write 3x divided by the quantity x plus 3 as an equivalent rational expression that has a denominator of x plus 3, x plus 5. So it wants a denominator of x plus 3, x plus 5, and all it has right now is that x plus 3. So we're going to look at how to get a denominator of x plus 5 also. The expression 3x over the quantity of x plus 3 has a denominator of x plus 3. The missing factor is, the missing factor of the denominator is this. Okay, so to introduce a common factor, we are going to have to multiply both top and bottom by that factor. So it's the same thing as multiplying by 1, right? Because if I multiply by 2 over 2, what is that essentially? 1. If I multiply top and bottom by x plus 5 and x plus 5, I'm essentially multiplying the fraction by 1. So that's what we're going to do. It wants x plus 5 in the denominator, so we multiply top and bottom by that x plus 5. So now this original expression is equivalent to this because I could reduce these out, but that would kind of defeat the purpose of what I want. What I want is the denominator to be x plus 3, x plus 5, and now it is. Okay, so this is now the equivalent one with that denominator that we wanted. So let's see if we can do that with B, or see if we can do part B. So it says simplify the expression. Doesn't say to rewrite the denominator. So let's just see if we can simplify. Write the expression, here it is, and factor the numerator and the denominator. So looking at my numerator, I'm going to have what multiplies to x squared is x, and what multiplies to 6 but adds to 5. So I'm not going to use 6 and 1, I'm going to use 2 and 3, because 2 and 3 will add to 5x. On bottom, I have this here that can be factored, and I have, let's see, what multiplies to x squared is x, and what multiplies to 2 but adds to 3 is 2 and 1, and both have to be positive in order to add to 3. And then don't forget, we still have this here, so let's write that x plus 3. And now we're simplifying, right? That's what the directions said to do. So let's go ahead and simplify, and let's see if we have any common factors that we can divide out. I see an x plus 2 here and an x plus 2 here. I see an x plus 3 and an x plus 3. And so on top, I have 1, right? Because isn't x plus 2 divided by x plus 2 just 1? So it's like the whole top is just multiplying by 1. And then left on bottom, I have x plus 1. So my simplified expression, I started with this guy, I factored, and then I divided out. And this is my simplified version. Now you have a U-turn that you can do here, or your turn I should say. There's two different ones. I'm going to go ahead and actually do the third one, your turn 3. And we are going to do what it says. It says simplify. So, well, let's simplify. I know that I factored when I was told to simplify here, so we're going to do that. We're going to factor the numerator and factor the denominator. So for this first part here, I know that I can factor out an x because both of these have an x, and I'm left with 1 plus x squared. And then for this one here, I can think of this as 1 squared minus x squared, and that's difference of squares. Now notice how this was not difference of squares, right? That's a sum, that's an addition there, so I can't use difference of squares. But for this second parentheses on top, I can. I'm going to get 1 and x, 1 and x, and 1 has to be positive, 1 has to be negative. So now I factored the top. Let's see if we can factor the bottom here. So I see that there's x squared and x6, or x to the 6th, I should say. So I'm going to take out an x squared, and I'm left with x minus x to the 4th. And this right here is difference of squares, so that x squared is just going to stay out front. And this right here, I'm going to get 1 and 1. And then what multiplied to x to the 4th? Well, that's x squared and x squared. 1 has to be positive, 1 has to be negative, right? And I really want to factor this completely, so I can't factor anything out of here. I can't factor anything out of here because this is sum, but this is difference of squares, right? This parentheses right here could be further factored to be 1 and x, 1 and x, where 1 is positive and 1 is negative. So this is my new denominator. Let me go ahead and write that here. So I'm writing this here. I have x squared, 1 plus x squared, 1 plus x, and 1 minus x. And now I'm going to divide out any common factors. So here I have an x minus 1 and an x minus 1. I'm sorry, a 1 minus x and a 1 minus x. Here I have a 1 plus x and a 1 plus x. Here I have a 1 plus x squared and a 1 plus x squared. And so it looks like I'm left with x over x squared. But if we remember, x squared is just x times x. So again, we have a common factor here that can reduce. And on top, I'm left with a 1. And on bottom, I'm left with an x. So this expression here, after 1 factoring and 2 dividing out the common factors, this is what I get. Alright, so a quick recap. I'm going to go to page 425. We went over identifying the excluded values, and the way that we did that was we looked at our denominator and we set the denominator equal to 0 to find which values the denominator could not be, or which values needed to be excluded. And then in order to identify your domain and range, we look at which values x cannot be, and based off of that, which values y could not be. Then we went on to explain 1, which is page 426. And we went over writing equivalent expressions, or rational expressions, where if you want to add something to your denominator, you have to remember you have to do it to top and bottom. And then the last one was simplifying, and that's where we factored our numerator and our denominator, and we divide out like terms. So we'll pick up explain 2 and explain 3 in the next video. Good luck!